So here is my Haas VF OE. It's a 1997 model. It's running, it's cutting accurately, it's all set up, it's got tooling in it, and this video will show how this was all done and how you can get a Haas in your garage. And to answer the question, can you actually fit a Haas in your garage, and what's involved. Now this video is not for entertainment, so I have dispensed with all the complicated editing, and I haven't put everything on footage for your entertainment. It's here to explain to someone who wants to do what I've done and put a Haas in the garage what is involved. So if you're watching this for fun, turn off now. This is for people who want to do the same thing. Okay? So it's a technical explanation of what needs to be done and all the steps involved. It's not a video for entertainment.
Alright, cut it right. Hard right.
Oh, yeah, hands told me.
What can we do about that?
No, yeah,
This right here is doing both of it?
all right.
Go brush and lump with that?
So the question arises, can you move a Haas across your garage that weighs 8,000 pounds on your own without a forklift? So the answer to that question seems to be yes. And the cost of all of this is that and 4 of these things off eBay. These, I don't even know what they're called, but I found them on eBay. I'll put in the description where you can get them. And this is a, I don't know, it's a 10-ton or a 5-ton toe jack. And these are $200 on Amazon. And they're fantastic. I didn't need to get a $200 one. I think I could have got by with a cheaper one, because when I'm jacking this, it jacks the machine up very easily. I jacked it up on this this foot here, and then I put these 2 in, and these things have got a hole tapped into the top of them already. That's how they come. And what I did is I took a chamfer mill and I made that hole a little bit cupped with a chamfer mill, so that the end of these studs would fit nicely into that little hole and center themselves in the hole. And now what I need to do is push, and the whole machine is moving across the floor. So that is just fantastic. Of course, your concrete has to be very smooth, and it has to be clean, because if there's obviously the slightest bit of stuff on the floor, it's going to get hung up. But it seems as though you can move your machine this way. So, woohoo! So I'm going to just show how you get 220 volts to your Haas mill through the phase perfect. So first you need 220 volts to the phase perfect. And if you look at a typical American breaker system, if you take out two breakers, you'll see that you've got two hot poles over here, and these are actually plus 120 and minus 120. So what I mean by that is that they're 120 volts out of phase. So across the two of them you've got 220 volts. So if you measure from here to here, you'll see you've got 240 volts. If you measure from here to neutral, you've got 120. And if you measure from here to neutral, you've also got 120. Now typically you'll have one of these things in here. So that will give you 120 volts to one of your plug stock, one of your wall sockets. But if you use one of these, which will go in like this, then you can get 120 volts across those two terminals. I meant 240 volts, not 120. And then your middle terminal, which is your neutral, comes from these white wires up here. That will go to the third terminal on the plug. And then your ground, which I've wired up to this copper cable, will go to your fourth terminal. So let's just look at the terminal. So here I've wired up an RV connector, and I think an RV connector is the best way to wire this up because RV is 240 volts. So this will be your plus 120, this will be your minus 120, I'll call it minus 120, it's 120 out of phase, and this will be your neutral, which is the white wires in the box, and then this over here will be your ground. So between here and here you've got 240 volts, and the same with this, although this doesn't have a neutral, it's just got a ground and a plus and a minus 120. Of course, again, I'm saying plus and minus, but I really mean 120 out of phase with the other 120. And then what I've done is I've just taken a thick copper cable and made it my ground, which I've wired all the way along. Now I've used this extra heavy outdoor cable. And if you look at this cable, it's at 6 AWG, so it's 6 gauge. So it's supposed to hold 55 amps. It's really heavy. I didn't actually need outdoor cable, but I got this on eBay very cheaply. So that suits fine. And then what I've done is I've gone from the terminal box all the way up along there and across the garage, and then I've gone down here. So this is where I'll be wiring up my phase perfect. We'll sit somewhere over here and we'll plug in over here. And this is a regular RV socket, so if I ever move, then I can just call this the RV socket and no one will ask questions. So that should explain how to wire everything up. This is the original connector, which I'm going to be obviously throwing in the trash. So here's it finally wired up, and it's all plugged in. The neutral is connected, the ground is connected, and it all works. And the only thing left is to label it. So there we have it. There's the new two connectors, so this one and this one. 50 amps. And one of these actually also powers the other wall socket that I have at the back. So I actually overhauled the counterbalance hydraulic cylinder, and this was a major undertaking as well. It's incredibly difficult to get apart. It's very difficult to get back together. It's difficult to find the seals to replace the hydraulic seals on the inside. And Haas themselves recommends that you not try to tamper with this thing, that you rather send it back to them and they'll send you a new one. And that undertaking costs, I don't know what it is, $2,000 or something. I don't know what their pricing is, but I thought it was too expensive and I was going to try to do it myself. So the first thing is actually trying to get this apart. So I made this little tool so that I could use the impact wrench to actually unscrew the hydraulic cylinder. There doesn't seem to be any other way of taking it apart, so I made this little part. In the next image you can see the all the different seals that I managed that I had to source. Now, once you have the thing apart, it's easy to measure the inside and actually find out what seals you get. They are actually standard sizes, but you do actually have to take the thing apart to measure it. And I actually found all the seals online. I could not find a local supplier to actually provide these, but there's the online seal supplier. I'll put the link in the description so you can get that. The other thing that I replaced was the hydraulic line, and it's a standard fitting as well. I'll leave the link in the description for where you can get your line made for you and shipped to you, and they'll make you a beautiful new line which won't leak. The older lines will probably be leaking as soon as you tamper with them. In other words, if you get an old machine, it'll appear to not leak, but as soon as you take it apart and put it back together, it'll start leaking because the line has become very fragile, and as you start twisting it, it starts to leak. Now, that's typical for hydraulic lines. So I'm busy charging this with argon gas. So at the moment it's on, well, this says it's on 800, but it's actually on 750. I bought a much higher quality pressure gauge, and you can see this pressure gauge doesn't fit in, and the reason is because the pressure gauges that are 1% accurate are all 2.5 inch, so it sticks out. So I've cut a hole in the side of the enclosure. Every time I up the pressure, I'm going up in steps of 100 psi. I actually flip this welding goggle down because you know, if this thing pops off, it could be really bad. Now, I've checked the pressure, I've checked if there are any leaks with this soap mixture, and there are no leaks anywhere, which is just what you want. This newer style of pressure switch doesn't fit in the old manifold block. This is the manifold, this is the pressure switch. So I bought this adapter, and that seems to seal. And I used this thread locker on it. It's actually not thread locker, it's thread sealer. This is Loctite 5452. It's quite expensive, and I actually don't know how it works because it doesn't seem to go hard. But I'm assuming that it goes hard under pressure or something. So this actually didn't seal in the end. It leaked the second, third, and fourth time. I had to take it apart over and over again. Here I'm actually machining that little adapter to fit an O-ring on my lathe, and that seemed to solve the problem. The other problem that I had is that but I mean, it's sealing. This Loctite is sealing. I don't see any leaks or anything. So I don't know if the Loctite sealed or whether threads were just good enough quality that they're sealed without anything. I don't know, but it seems to work. I had to actually splice these in because the older style pressure switch has got a different connector. So I cut this connector off and I spliced it in, and now everything works fine. The other problem I had was this style of regulator. The one that I had actually does not go all the way up to 750 psi. It goes up to 500 or 600 psi. Now, I didn't know that having the gauge go up to 1000 psi does not mean that the regulator will go up to 1000 psi. The regulator may only go up to half of what the gauge tells you, depending on what model it is. Now, this is a different model of a regulator, and I mean, the other one I've still got, but this one apparently goes up to 800 psi. So we'll see if it will go all the way up to 800 psi. Now, I actually needed to go up to 790 psi because that is the psi when the a counterbalance hydraulic cylinder is extended. So, I mean, you'll see right here it says top of travel is 750 psi, but the bottom of the travel, which is when it's fully extended, is... Sorry, I got that the other way around. The bottom of the travel is 790 psi. The top of the travel is 750 psi. So when the bottle is fully extended, it means that it's actually compressed the most, which means that it's 790 psi. So just get your logic correct there. So as the z-axis goes up, fluid flows out of the bottle up this hydraulic line, and the pressure goes down. So that all makes sense. So now I'm going to go, I mean, I'm on 750. I'm going to go up to 790 as required, and then I'm going to leave it at that. I mean, I'm actually thinking of leaving it at 750 right now and seeing what happens, because I always put more gas in later, but it's very difficult to take gas out. So I'm not really sure what to do, but I think I might just leave it at 750 and then see. And then what happens is I'll raise the z-axis and then see if the pressure drops, and then bring the pressure back up to 750. That explains all of that. This is a 1/4 inch style hydraulic connector. It fits directly. I think all these manifolds take what's called a 1/4 inch style connector, which is 1/4 inch inside diameter of the pipe, and the actual thread diameter is much larger. And I mean, I don't know anything about these hydraulic connectors, so I always thought that 1/4 inch meant the thread size. But when you're talking about these, 1/4 inch does not mean the thread size. 1/4 inch means the inside diameter of the pipe. This is 1/4 inch, and this is some other one, and an adapter I'm actually going to show you in the video description. I'll give a list of parts for this. So here's everything installed. My little hole there is quite neat. Just clears the dowel. Here's the piece I cut out with a hole saw. Everything does not seem to be leaking, which is good. At least I don't see any leaks. So I'm going to leave this overnight and see what happens. I mean, there would have been air coming out the top if there was any leaks, so it's unlikely that there's any leaks at all. But I've cleaned this area quite well, so if it starts leaking, it'll be fairly obvious because hydraulic oil will be all over the place. So for a domestic foundation, you want to have support under your foundation, otherwise you could actually cause your house to sink if you don't have a solid substrate under the foundation. Now, what I did is I got this foundation repair company to install pylons at strategic points to actually keep the garage from sinking, and that way my foundation can remain level. So one of the reasons I'm rebuilding this is all of these things were worn out. So if you look at the originals, you can see what's happened there. This tool changer wasn't aligned, and every time the tool would seat, it would actually wear this out. So I've ordered a bunch of these. I found them on eBay. Someone was selling a bunch of them. So that's one of the reasons I'm taking this whole tool changer apart. So to give you an idea how dirty this was, this is what this all looks like after you take it apart. I mean, this is disgusting. So here's some of the other things I'm doing. This is the new oil pump which I installed. Slightly bigger one than the original, but I noticed they kept the bolt holes in the same place. This bolts in just perfectly. So if you want to actually see it get to pressure, I suggest putting a video camera on it and recording for half an hour and then going through the footage, because it only actually pumps once every half an hour or so. So standing there and waiting for it to pump to verify that it's working can be quite frustrating. This pressure sensor was leaking, and also this hose here, which you can't really see, but the thin hose at the back there, that was leaking. So I bought the new hose, and I had to machine the clamp nuts a little bit to get them to work. Look closely as these. I found these on Amazon or eBay or something, and they are meant to prevent the nylon oil hose from being crushed. And they've also got a little ferrule there, which is what actually seals everything. So if I use the original tightening nuts and bored out the inside of the tightening nuts, it fits nicely over there and all fits back together. So that I was able to get everything restored. It doesn't seem like you can actually buy these nuts. You have to use the original nuts. And then of course Haas sells this nylon line for the oil. There you can see the specification. I mean, you can get this nylon line anywhere, but I just bought it from Haas because I'll be sure we're getting the right thing. It's not that expensive. So another thing leaking was this this pressure sensor here. So I replaced that one as well. It was very difficult to get off. I actually had to destroy it to get it off. And that seemed to be the only leak in the head. I did a lot of investigation to figure out what this is for, but this is actually the low oil sensor for the transmission, and this system doesn't have a transmission, so it's not needed. Haas just joined these together, and I just put in this blue line to make it a bit neater. So if you look here, these wipers, this cover is a wiper. I accidentally damaged it when I was trying to clean it. The plastic goes very soft after many years, and if you try and rub a toothbrush in there or rub anything sharp in there, it's actually going to eat away the plastic. So I found these in Germany, and they had sent them to me. The shipping was horrendously expensive, but now they've been replaced. And the other problem was that I actually dropped two of the bearings. I actually dropped 4 of the bearings. I found 2 of them. These bearings are 1/4 inch plus 4 micron. That's 1/4 inch plus 4 micron. That's 4 thousandths of a millimeter. So this odd size is, it has to be exactly on size. Because I've only lost 2 of them, I actually went to McMaster and I got 1/4 inch bearings with a specification of 1 micron. And I put these in. I put 1 on each side, 1 over here and 1 over here. And that shouldn't make a difference, I think. I don't think it makes any difference if it's just 1 bearing. It's very slightly undersized. The bearings have all the properties of bearing steel. McMaster car bearings are a very high specification. So, and then with a new wiper, everything looks back to normal. And then I cleaned out all the inside of this, was full of junk. There's still a lot of junk here, you can see, but I'm going to leave this. Cleaning these is fraught with danger. Because I did damage it. So to get an idea how dirty this tool changer was, you can see there are chips in there where they're not supposed to be any chips. So everything was really in a very poor state. Here's the cover of the Z-axis. And I put in new sound dampening, and this sound dampening is actually for cars, and I've used some fancy spray to tack it on, and I've also put in these rails here to actually screw it on so that it doesn't move. I'm scared it's, the tack spray is going to come loose and these are going to slide down. So I've screwed these in here, and I've put screws on the outside which look quite neat, so that should be no problem. And then you can actually buy this generic sized filter. So I bought a new filter here. So cleaning this Z-axis cover was very difficult, but I mean it's now all back to, it's now all cleaned, and I used the pressure washer, so essentially it's been restored. There's no damage to it on the outside, paint looks all intact, so it's ready to actually go back on the machine. So you may ask, why did I take this apart? Well, I was just taking the scraper off, the wheel scraper off, which is the top cover. But then I thought that the next thing was also kind of a cover. I wanted to see underneath there if there's anything wrong with it. So when I unscrewed it, I realized that that is actually not a cover at all, but it's the guide for the ball bearings. And if you take it off, the ball bearings fall out. So this was a very silly mistake, but now it's it's all corrected now, so I guess it's okay. So here are the old wipers. You can see how in bad condition they are. And these are the ones that you buy from this German company. and they're very nice and they're an exact fit. These are the McMaster high precision bearings, and I think they're 1 micron accuracy, or they're it's a half a 10,000th of an inch. And these are the 2 micron, which is 1,000th of an inch. And these ones were no good, they were undersized. They tell you the specification is between a certain thing, but what they really mean is that you may get a whole batch of undersized bearings, which is useless. So I phoned THK, who makes the bearing block, and I asked them if I can put a ball bearing there, and they said that in fact their factory, when they assemble a rail, will actually try, they've got 3 different sizes of bearings which they will try. Sizes of balls, and they will try all 3 until they get the right preload or the right resistance. So, you know, you're dealing with something which is very high precision, so you can't just put any balls in there. You have to do, you know, their procedure, and they're not giving out to the public these different balls of different sizes. So I actually bought this micrometer to measure the size of these. This was only $40 on Amazon. It's very nice. It's eye gauging micrometer, and it shows that these are much too small, but the precision ones, which are these, are okay. So, I mean, they're 4 microns under, which is too small, but it's good enough. And I mean, these also definitely are very highly polished when I look at them compared to these, which are actually not so highly polished. So I'm going to just show how you install these, because it's actually very difficult to get the spring in. So the first thing I did was I sprayed this with Rust-Oleum, and then I left them overnight, and then I baked them in the oven at 300 degrees. And you have to bake them for an hour, and you have to do that 3 times before they get really hard. So if you want hard paint, and paint that's not going to chip when you scratch it with your fingernail, then you've got to do that. I've wire brushed both sides, and I've made sure that these are actually flat. So if you look down the edge of them, I've straightened them all out so that they're flat. And if there's any curvature, I've made sure the curvature is in the direction that when the screws tighten up, that it flattens out. Because typically they'd be bent in the other way, because all sorts of junk had gotten underneath here and actually pushed this out. So you've got to make sure it bends the other way, so when the screws tighten, it goes flat. So the first thing to do is to put a bunch of grease on this side, and the reason is, well, firstly, you don't want this to rust again. You don't want to paint this side, because then the paint's going to rub off and get into the groove here where the spring is. But you do want grease to soften rusting, and you also want grease so that it sticks to the aluminium backplate, because it's going to want to lift up with the spring, and with a bit of grease there, it actually will vacuum seal itself down a little bit. Not a whole lot, but a little bit, and that helps keep it in place while you're working on it. So that's step number 1. The next thing is you want to very lightly clamp this so you can still slide it, but then it won't lift up. And then you want to leave about 1 inch of space over here. So then you get your new springs, and I'm going to put in the description where to get these. And you slide it in, which that's about as far as it goes. These I've also wire brushed till they're nice and clean and made sure that they're perfectly flat. Now this one is not flat, so this one goes in the trash. This one is perfectly straight. Now some of these have got like a slight divot there where the tool has crashed in hundreds of times from the tool change, and that's actually fine because that's not in the way of anything, and it's so small it allow chips in. So that goes in like that. And then you've got to make yourself a little tool like this out of some welding wire, which is easy to make. And then you've got to make yourself a little tool like this out of some just plate metal, and you can just use a Dremel to actually make the shape at the end. So I use the Dremel flat grinder to actually just artisan carve this shape, so that will fit in like that. And you're going to see how I'm going to use this right now. So we push this wire in like this, and then with these two fingers I'm going to hold this down, and then I'm going to go like this. Well, first I'm going to put this in here. With these two fingers I'm going to hold this down, and I'm going to go like this. I'm going to push this in and pull this out, and then slide this across. Okay, I'm going to aim for the bolt holes so the bolt holes align. And now that I've slided it all the way as far as I can go, I lift these out and slide it all the way over. So now it's slided into place. So now I can get some screws and screw this in place. So that's screwed down. And then I'm going to need one of these screws here. Okay, that's screwed down now and is not going anywhere. So the next step is just to Loctite these little screws down. Feels like it's cross-threaded. Okay, so this one is actually stripped, and it wasn't stripped by me. But actually this is the first one I've come across that is stripped. All the other ones are fine. So, I mean, I didn't put enough force on here to strip it. It was already stripped before. Okay, so the solution to fixing this is just going to be to put a nut at the other side or something like that. It's quite a coincidence that as I started filming, I found the first one that was stripped. So that I find quite astonishing. But you can see this works just perfectly now, and is releasing as it's supposed to. So now I've got 9 more of these to go. So I found a way of fixing the stripped nut with a stripped hole. So what I did is I got one of these rivet nuts, and this seems to be the right size, so I can actually screw this in. These are stainless, and I'm not going to use them like you're normally supposed to use them. What I did is I ground it down a bit shorter So this length is the same thickness as the aluminium backplate, and then I hammered it in from underneath. So just to give a close up here. So that's what it now looks like. So I'm going to just go underneath here, so maybe you can see. So that seemed to work very well. There seems to be only one stripped nut in this whole affair, which is quite fortuitous. Because some of these were badly damaged, I expected more of the bolts to be pulled out, but there was only one in the end. So now I'm just going to Loctite this in here. Now I put a bit of JB Weld when I hammered in, so that, you know, for extra security. So there we go. That's fixed, and that seems to tighten up quite well. So here's a shot of the tool changer front and back side. The restoration of the tool changer is a massive undertaking. It really is a lot of work because there's just so many screws that you have to deal with. Now the tool changer was in a terrible mess. Many of the pockets did not work and were bent, and the covers were bent. It was really in an appalling state, and trying to find the different parts and so on is quite difficult as well, because Haas only sells individual pockets, and they're very expensive. So you're going to buy 20 pockets. I mean, you're really going to spend a lot of money. So the best thing seemed to be to get some of the individual parts from the aftermarket, and then take, you know, what parts that were salvageable and actually bend them straight and repaint them and so on, and that seems to be the best way of restoring it. And it's quite cheap. It was quite cheap in the end as well, and it gave a perfect result. So you may have a problem that this piece in the tool changer does not line up with the keyway in the tool, and then what happens is you get this kind of wear, which I don't think is healthy. So there's actually two issues that this could be caused by. So the first is the orientation of the tool when it stops. So if the tool is offset slightly a couple of degrees, then when it does a tool change and this comes in here, it's not going to fit in the keyway exactly. Now in some of these Haas this can be corrected with a parameter, and you can look at the tool rotation stop help on the internet, and that will show you how to set it through the console. On this one it doesn't have the vector drive, so the way to fix it is to go up here and adjust this timing chain sprocket. So you can see the smaller sprocket at the top of the motor. That sprocket can actually be rotated. So you can use that, and then you can also rotate the whole assembly at the top there. Now, there's a sensor pickup which determines the rotation of the tool when it stops. So that can be adjusted to get this in the perfectly right angled rotation. Now the other problem is that the whole carousel, the whole umbrella, can actually be too far forward or too far back. And that's easy to adjust. All you've got to do is you go to the back of the machine, you move this panel, and there's 4 large nuts in there. They require a 19mm socket wrench, and you loosen all 4 of them and you hit this with a hammer. Well, they say that you can use a pry bar on one of the bolt holes as well, and you can actually move this whole assembly forward or backwards. Now I hit it with a hammer because I needed to go forward, and after about 20 hits I was able to move it about a 32nd of an inch, which is what I needed to get it aligned. So now it aligns perfectly. So here you can see you do a tool change, and it's smooth and it's got the perfect action. And we're done. So we're not actually done. You'll notice that the tool rotated an extra time before it stopped. And this is because the tool stop is actually worn. So if you've got a heavy tool, if it's rotating too fast, it's not going to actually stop inside the valley. The pin that stops the tool is actually going to bounce out of the hole. So the way to fix that is actually very easy. You don't have to replace anything. You just have to change the rotation speed of the tool for the tool change, and there's a parameter for that. And if you lower the speed, then everything works perfectly after that. That's what I did rather than replacing any parts. So if you have a Haas in your garage, you cannot actually get this front cover of the Z-axis on without removing this cross brace. There's a cross brace here, and it's got some other braces, which it's got a rail that comes underneath here which the doors slide along, and another rail here. And the only way to get this in is to remove this cross brace, and to remove the cross brace you need to get the doors removed. So here the doors removed. I need to clean them and do a little bit of stuff to them. Then once you remove the doors, then you can remove this door sensor here, which I've just put out of the way. And with the door sensor removed, then you can unbolt everything else. And then you've got space to actually get this covered. Because of the height of the ceiling, you can't get this covered in. The Haas technicians actually lift the cover all the way up 15 feet in the air to get the cover off. So if there's any doubt that this can fit in a garage, you need to watch this. So as you can see, it stops just before the ceiling. Now this ceiling is exactly 100 inches high. That's 100 inches, give or take a quarter of an inch. And the bottom of this house is almost right on the floor. So that's what gives me that extra couple of inches, is I put this on pieces of plywood instead of usual mounts. Now, of course, I'm not counting the hole in the ceiling for the cables, which pokes up through the ceiling a few more inches. But it seems like this was designed to fit in a garage, which is quite bizarre. Who would have thought? But it seems like it's designed to exactly fit. So there you have it. A Haas can get into a regular two-car garage. So the other problem I had was someone had stepped on this, and you can see they've cracked this. So this was bent down. So what I did is I actually made a brace with a piece of metal, and there's an extra screw over there which isn't normally there, and that bends it straight. So now the door will actually slide easily. So I guess the next question is, how the hell does the garage door open? So I'm going to show you right now. So first, you know, this is as far as it can go. And then we just open the garage door. And you can see that this misses, and that's got a little bit of a cutout in it. And there we go. So the next step in this whole operation is getting the cooling system working just right. So I installed this filter system from McMaster-Carr. McMaster-Carr doesn't have a whole lot of variety of fittings. So for garden hose fittings, so these threads are called GHT, which stands for garden hose thread. And garden hose thread is a standard. So if you search for GHT, you'll find a lot of different fittings, but not that many on McMaster. So I got a bunch of fittings, the part numbers for this and the filter I'll put in the description. I cut this original Haas hose, I heated it up and I pushed it over this fitting here. I've made these garden hose fittings all disconnectable, so you can disconnect this or this or this and move things around if you need. Here's another one. This is a Y fitting with 2 valves. This one goes to a spray gun. So let's look at what else I've done. There's a cheesecloth in there. Here it is. This is a McMaster part. I'll put the part number in the description. The second Y part comes to this hose, to this spray gun. So this is very useful. Let's watch this thing work. So we'll turn on the chip auger. There's the chip auger working. And we'll turn on the coolant. and there's the coolant working. So I turn these valves down a bit so the coolant doesn't splash, but you know, they would be gushing out of there at very high velocity. Here's the spray gun. So if I squeeze it all the way, you see it really sprays quite hard, and it creates a lot of foam actually. But this is very useful for washing things down. So you get the idea. So this spray gun is only a few bucks and curiously seals perfectly with no leaks when you lift up the trigger, which is very nice. So here you can see the fluid coming out onto the cheese block. And here's the fluid. It's foaming a bit because of the gun. And it's being sucked up by the pump. Then filtered and then going to the machine. So that part of the project is now done. So the next step is to try and level the machine. I actually am not trying to get this machine level, but I do care if the machine is twisted. If the machine's level, it actually makes no difference. You know, if it's canted at an angle, it actually is not going to affect your work accuracy, but if it's twisted, I mean, that is quite serious. So I'm going to try and see if I can get any twist out of it. So the first thing to do is to notice that there's an access panel over here, and inside there is a bolt which you can turn to twist the machine. So I've taken this access panel off, and then I've actually raised the machine with a toe jack. So here you can see the toe jack at the back of the machine. It's just next to the center mount, and all around the machine I've got these mounted on plywood. So I jacked up the machine, and then I put one of these instead of plywood under there, and I actually chamfered this hole out so that the end of the bolt will actually, the stud will fit actually into this nicely. So I could turn that to twist the machine. So that seemed to work quite well. Here is the outcome. So you can see the position of the bubble. If you look there, it's just one division left of the long line. So to check if the machine's twisted, I'll just move the y-axis. And now you can see it hasn't moved at all. This tells me the machine isn't twisted. Now if you look at the precision of this Fowler level, it's 2/10,000ths of an inch per 10 inches. So that's 5 microns per 10 inches. So over the length of the table, and you can see, I mean, that was one division, but I mean, how much did it move? It probably only moved a micron. So, I mean, over the 30 inches of this table, we're looking at a very small amount, 30 inches of travel. So, you know, I'm going to take it that this is now not twisted anymore, and the machine is ready to machine. So these fowlers come in different lengths and different graduations. This is the most accurate one. I think some of them are 1/1000th of an inch, 5/1000th of an inch, or whatever. And they come in different lengths. I think there's a 12-inch one and a 6-inch one, or something like that. So I didn't think that one longer than 10 inches was worth the money. And also sometimes you want one that's slightly smaller, depending on what your work is. So I thought the 10 inches was just about the right size. It's got an adjusting screw, and at the moment I've not calibrated because I don't actually care whether it's absolutely level. I only care whether the machine is twisted. So the next test is obviously going to be on the x-axis. So let's move the x-axis. So let's just wait for it to stabilize. So that looks good. And then we can move all the way to the other side. So that looks good too. So this machine is dialed in now. Now the only other thing I guess I would fix or try and calibrate is the backlash. So maybe I'll get to that a bit later. Now I do notice when I move the table into the far corner, I have a half a division or one division of unlevelness, but that doesn't seem to be serious. So I found this to be quite amazing. This is a US solid valve that is operated by a 12 volt supply. The range of voltage is from 9 to 24 volts. So by default it is closed. And when you apply a voltage, it opens. So let's apply the voltage. So there you can see it's opening. And when I release the voltage, it automatically closes. Isn't that awesome? So here we are at the back of the machine, and I've put in this 25-gallon drum air tank, and this should solve the problem when I'm trying to do many tool changes in a row and I run out of air. So you can see my tiny air compressor here, which doesn't have enough power, but with the tank it works actually quite well. Here is the electric valve which I explained previously, and I have this wired and going into the box, and you'll see it actually goes into this 12-volt supply, which seems to work very well. So essentially what this means is that when I power on the machine, it opens this valve and I've got immediate air compressor without having to wait for the air compressor to charge the thing up. So here you can see this goes in and this is the outlet. Now at the bottom I've got this automatic drain system which leaks no air and constantly drains this water. So this effectively means that I've got a completely automated system. I can leave this on all of the time, and when I turn the machine on I've got instant air, and at the same time I don't even have to wait for air to charge up, and I don't have to do any maintenance on this thing. I can just leave it. So that's an extremely good solution. Now how I've got this mounted here you can't really see, but let's see if we can look down there. So I drilled a hole into the side of the casting, and I made a small bracket, and I welded on these tabs over here. So this thing mounts nicely vertically and drains from the bottom. Now this bung didn't exist. I actually cut a hole and welded on this bung so that I could install this on the bottom. So now all the fluid, all the water leaks through this, and there's never going to be a case where it starts to fill up with water. So that makes for a very nice solution. So just to explain that the whole point of having the valve here is that with the valve here, once the valve closes, this whole system is completely sealed. There are no leaks anywhere. This does not leak. This compressor system is completely leak-free. None of these connectors leak, and this doesn't leak. So the result is that this will actually stay compressed even if I leave the machine off for a week. When I come back, I've got instantly a lot of air available. So that's the idea of the whole system. So the next part of this project is this oil skimming system. So this is really one of the cheapest ones you can get. I've gone ahead and just tack welded it onto this square stock, and then I've put a screw in over here, and it's just draining into an old glass bottle. Now this thing is not meant to operate 24/7, and I think it would be pretty stupid to do that. Probably only needs to run about an hour a week. So what I've done is I've got this digital timer, which is just a few bucks on Amazon, and I've set it to run at intervals. I'll put the link in the description where you can get one of these. And so this is now a completely automated system. I don't have to do anything. I can just leave this running forever, just like the air. I don't have to turn on my air compressor, and you can hear my air compressor is now on, and it's completely silent because the tank is full and is not going to empty. So setting yourself up this way I think is extremely important, because it just adds to the convenience of the whole machine. And even though I'm only going to run the machine once a week or something like that, I don't want to have to do anything when I run the machine. I want it to just sit here and automatically maintain itself, and that is a great convenience. Now there is a much fancier oil oil skimmer, which actually sucks up the water and pumps it into a filter similar to this, separates out the oil and then pumps the clean fluid back into the reservoir. I am not interested in that. They're quite expensive. They're over $500. I don't think I need that. I think this is good enough. This is draining nicely, and there was a lot of junk on the surface of this cutting fluid, and now after running for an hour it's completely clean. So that's very cool. So I ordered all my tooling and my tool holders, and I used CME Tools, which has got one of the cheapest tool holder sets that you can get. They claim a 1/10,000th to 2/10,000ths run out of their tool holders. Now, when you actually stick this in the spindle, and I've tested my spindle has a run out of less than 1/10,000th, so my spindle is essentially perfect. When you put this tool holder in the spindle and you check the run out of the inside bore of the ER32 collet, so you remove the collet and you check the taper inside the tool holder, you will actually find that this is a run out of about 5/1000ths. Now, I didn't check a lot, I only checked one of these, but I'll explain. They all seem to have this property. Now when you tighten up this tool, you'll actually find that and you put your dial indicator against the carbide tool, you'll actually find that the tool has a run out of as much as 7/10,000ths. And this is, I don't know how many people actually measure the run out of their tools, because I've got an impression that many machinists don't even bother measuring the run out of their tools. But some other YouTube videos say this is very important, so I'm going to go ahead and do it. They say that for each 1/10,000ths run out of your tool, you decrease your tool life by 10%. So I thought it would be useful to actually get this all dialed in very perfectly. So I was quite surprised to see the run out was in one case 7/10,000ths. So here I have an array of tools installed. I've got this regular draw chuck, which can be quite useful, but I just got one of them, and the rest I've got the collet chucks. I think I've got a 16 collet chuck and a 32 collet chuck. Most of them are 32. I bought this giant face mill, which I'm going to try out now. I bought this style of mill, which is an onion-degree shell mill. And then I've got a variety of carbide milling cutters, and I've got a bull-nosed milling cutter. So that seems like a good array of tools. There's a lot more stuff that I'm going to get, but this is just to start off with, to do some basic cutting operations. Now, I did check the offsets of these inserts on the shell mill, and this is also CME shell mill, and the offsets between each tool, between each insert is quite large. They differ by as much as 1/1000ths. So, one of these is going to come around and do 1/1000ths deeper depth of cut than the other one. And the other, if you're taking a small cut, you're going to find that obviously it's not going to produce a perfectly flat surface, which is a problem. You're going to have to go very slowly, and there's probably going to be one tool that's actually going to do your cutting if you're doing a fine finish. But it depends what you're going to use this for. I don't know what to expect from shell mills and how accurate they're supposed to be. So I'm going to take my first cut with the shell mill, and I've written this little program. So here's the program. as you can see, what I'm going to do is going to take a straight cut at a speed of 10 inches per minute across the top of this block of steel. That's the whole thing. So I dialed in this vise very accurately. It's got only a couple of ten thousandths of runout across the top of the vise and also the face of the vise, which is very nice. And this piece of steel, I don't even know what it is. I think it's just some basic mild steel, nothing too hard. Okay, so it's just managed to skim this, and I can just barely feel where the tool touched. So I'm going to go another 1/1000th and see what happens. Okay, so I've gone 1/1000th down, and now I can start the program again. Okay, so this is not a particularly good finish at all, obviously, because these inserts are not perfectly planar. So let's I'll increase the speed a bit so I can get a finer finish, and maybe I'll decrease the feed as well. can definitely smell the smell of cutting metal. Well, that feels a lot smoother. That's a very nice finish. I mean, that feels glass smooth. So it's still a bit rough on this end because I think this end is lower and it's not cleaning up completely. So I'll try another 1,000. Can run again. So it sounds like it's making a very nice sound. It's quite a solid thud with each turn, which is, I mean, it's machining properly, I would say. And of course, this is all unknown till now because this is the first cut that I've ever done. You can definitely hear that one of the inserts is lower than the others, and it's taking most of the work. I can't tell if it's cleaned up all the way. I think it has. So I'll just wipe this. I think it still has to clean up there. Okay, so maybe I should try a bigger depth of cut just for interest. So let's take another 3,000 off and see what happens. Very smooth. It feels glass smooth actually. Although you can feel that it's smoother. There's the slightest hint of striations in the metal, but that's pretty nice. So that cleaned up all the way. Okay, so we have confirmation that it does actually work. The machine works. It cuts, and I guess that's all I can say at this point. So here's a close-up of the surface finish. So that looks very good to me. I mean, perfectly acceptable. You see that this is where the cutter lifted up, but you can't actually feel it with your finger.